Hello, welcome back to the channel. In this video, which is part 2 of the inequalities for the video series related to algebra, we are going to continue from where we left off. Basically, we have another example, which is x squared minus 3x is greater than 0. Again, this is very similar to what we did when we were introducing this topic of algebra. So if you're given this situation, all you need to do now, you just need to find the factors. We have already found the factors before, so the factors are just going to be x equals to 0 as well as x minus 3, like that. So you can just factorize that by taking x out, and then you have what we have now. From there, now we need to determine what they call critical criticality. That doesn't make sense. Critical points. Okay, the critical points will be basically what you would have if you had the inequality sign there and you were supposed to solve for x. It's just going to be x equals to 0 as well as x equals to 3 from there. And now all you need to do is a timeline like that, and then just need to put your critical points on the timeline and put some circles there on top, because there's no inclusion of the critical points, which is supposed to be indicated by this equality sign that they usually put under the inequality sign. We don't shade these circles, okay, which just shows that we are not going to include the critical points. Why did I say the other critical point is 0? The other one is 3. There's 0 and 3. Okay, at this point all you need to do is to try to test this part of the inequality and check between when you substitute an x value which is less than 0, which is this side, and when you substitute 1, which is between here 0 and 3, and when you substitute an x value which is to the right of 3, that means greater than 3 this side, what will be the signs of your answer, so that we can evaluate a range of x whereby this inequality is true. Okay, so we're just gonna think of any value that is less than 0. In this case, we're gonna start with maybe -1, and we substitute it there for x, and then that is in the brackets, and then now we substitute the value again for x. This x, it's going to be -1, and then we subtract 3 like that, and then we check what our answer is going to be. -1, -3 like that. The answer is +4. We're interested in the sign, then we write the positive there. Okay, and then we look for another value of x which is between 0 and 3. That could be +1. It's between 0 and 3, and then we check what answer we're getting. Okay, I'm just gonna quickly do that. We get -2. We're interested in the sign of that. We put the negative there, and then we also check for any value which is greater than 3. In this case, I will take 4. Okay, and what answer do I get when I take 4? I get +4. Okay, I get +4. I'm only interested in the sign, then I take that sign there. Okay, now that we are here, we can write our final answer. Our final answer is just us indicating a region where this product is going to be greater than 0. Okay, that region is this region between 0 and 3, because you've proven that for any value of x that we can think of between 0 and 3, the product of these two, this one as well as this brackets, is just going to give you an answer which is negative. Actually, I think I'm wrong to some extent in what I just said. We're actually looking for a region where this product is greater than 0. So that is actually not this region. It's this other regions, these two regions. That's where we have proven that this product gives you a positive value according to our calculations. So sorry for the confusion. However, I believe now we are on the same page. Okay, so we just needed to indicate these two regions, which is that one as well as this one. So let's just now write this in inequality notations. That is a region where, or this region, this side going there from x is less than 0 and x is greater than 3. You can see that's where this product is actually positive. Okay, you can also write it in another way, which is to write it like this. X is an element of from -infinity up to what? Up to 0. So for infinity sign, we always try to use this what you call the circular brackets. Okay, so with infinity sign, there's no need to indicate whether or not you're including the infinity. You always use the circular brackets. Okay, and okay, x is an element of from 3 all the way to positive infinity, you always use the circular brackets. But for the other digits or the numbers, we are basically going to use circular brackets if we are excluding this 3 and this 0. In this case, we are excluding them because we didn't shade here. We didn't shade those circles for the reasons that I just explained previously. Okay, that is basically how you can write your answer. You can write it either in this way. Okay, I thought you can write it in this way or in this way, whichever way you prefer. You don't have to write both. That's why I'll say or. You shouldn't write both, actually. You should just write one. Okay, that's basically the answer for the problem. Let's look at another problem. This other problem, we have x squared. It's greater than or equal to 4. Okay, again, what we need to do now is just to move this 4 to the left. We're going to have x squared minus 4 is greater or equal to 0. And then from here, the next step, as usual, is to find the factors. The factors for this perfect square is just x plus 2 as well as x minus 2 being greater or equals to 0. Okay, from there, we need our critical points. Just standard procedure, cute. Okay, critical points, just what you will have when you solve that equation or the inequality with an equal sign. It's just going to be x equals to negative 2 as well as x equals to positive 2. Okay, some they use and here some they use or. I've never experienced a problem from the B.Ed gang with regards to what you use there. It seems like they are happy with whatever you use. However, I'm not trying to be a substitute for the B.Ed gang. You can always ask them which one do they want and then we just do that. Okay, if you're interested in the reason as to which one they want, you can also ask about that and then they shall respond. Okay, and now we just continue with our problem. The problem is now we draw is this, what is it, a number line, and then we shade these circles of ours simply because we are indicating that we are including these critical points. The reason for that is because there's this inequality or the equality under the inequality. I don't know which is the simpler way to say this, but when it's greater or equals to, we are including those things. Even when it is less or equals to, we are including those things. By those things, I mean the critical points. Okay, from here we just need to identify the signs between this side, that side, as well as this side. Okay, so we're just gonna look at what we have here, this product, and then we do some substitution again for when x is less than negative 2. So we're gonna put like negative 3. Let's just take negative 3. We put it there in the place of x inside the brackets. Then we say plus 2 like that. And okay, I think there's too much movement. We put it like that, and then we're gonna put that negative 3 again in brackets minus 2. And then you tell me what answer you get there. Okay, you can't tell me now because we are not in a live session. So I'm just gonna tell you. Minus 3 minus 2, we get positive 5. So we are only interested in the sign. We take the sign of positive there. Okay, while I'm still on 3, I'm just gonna put positive to check this side. Okay, and the answer that I get is positive 5 again. So I'm still this side, it's positive. So in the middle, I'm just gonna put, you can put 0. Put 0 there, I'm getting negative 4. If I put 0 here, 0, 0, I get negative 4. So I'm interested in the sign, I'm going to take the sign there. Okay, now it's time for you to write the final answer. This is just a game, guys. Writing the final answer, this is basically dependent on what we have as our inequality sign. The inequality sign says greater or equal to 0. So the region where this product is going to be greater or equals to 0 is this region, because greater or equals to 0 means positive. Is these two regions. So we need to just use the inequality language to state what those regions or which regions are those. Okay, the inequality language says that this is the region where x is less or equals to negative 2, and it's also the region where x is greater or equals to that positive 2, because from here you go there, from here you go there. Okay, the other way to say the same thing is to just say this. I'm gonna put an or, say x is an element of from negative infinity all the way to negative 2. So this negative 2, we're including it, so I'm going to put the square brackets. Union, like that, we call the union, some they call it an or. Basically, we say the same thing. From the positive 2 all the way to positive infinity. Again, with the infinity, we always use circular brackets. We don't need to indicate whether or not we're including the infinity, because we don't know what's going on there at the infinity situations. Okay, this is how you can write your answer. Now we move to another example. This another example thing that we are moving to. it's this kind of question. Okay, let me write the question for you. Where is that question? Seems to be disappearing. Oh, it's 1 is greater than 3 over x. Yeah, they're trying to make life interesting. So we have an example of a fraction. Okay, when we have a fraction, we just need to learn how to deal with fractions. We don't say life is becoming too complicated. We just need to learn how to deal with fractions. Okay, yeah. So you have this fraction. The first thing you can think of is that how do I get rid of this fraction politics? So you just need to multiply both sides by the square of the lowest common denominator. Okay, that's how you're going to eliminate the fraction side. The reason why we multiply by the square of that lowest common denominator is to ensure that what we are multiplying by is positive. That's why we square it, because when we square it, we are definitely sure that the answer of whatever it is that we squared, it's actually going to be positive. Okay, so to multiply by it is to eliminate the fraction. By squaring it is to ensure that it is positive. Okay, then if it's positive, it doesn't affect the inequality sign. That's basically what is happening. So let's do that. We're going to multiply by the square of the lowest common denominator. The LCD in this case is the x. So we square that and multiply both sides by it. What am I doing? This is 3 over x, and then we multiply that by, okay, let me just move this thing here so that we can stop having this nasty voice and sounds. Okay, I'm gonna put it like that. So now that we are here, we have x squared is greater than this, cancels that, now is greater than 3. That means we have x squared being minus 3 being greater than 0. I hope now we are getting somewhere. Oh, it's 3x, not just x. Okay, hey, sorry, people. And then we just factorize now. This is going to be x minus 3 being greater than 0, sorry. So we have our critical points at this point. Critical. Why do I just write things which are not supposed to be written? In terms of critical points, what do we have? We have x equals to 0 and x equals to 3. Then now we just draw our famous number line. We have 0, we have 3. Then we are basically back to where we started. This is similar to what we already did before. And because the inequality sign does not say greater or equals to, it's just greater. We don't shade these things. That means we don't include the critical points in our final solution. So now we're just going to substitute. We'll put a value which is less than 0. That's -1 or any other value that you can think of. And then we realize that the signs that we're going to get is plus. Then we put a value which is between. By putting a value, we still put them here in place of x. Okay, so we're going to think of any value between 0 and 3. That's like 1. We're going to get negative here. And then we take a value which is greater than 3. That's like 4. You can think of 4. You can think of 12 or your age. And then you can put it somewhere. And then you get that this product gives you a positive answer. That's why I took the positive sign there. Okay, at this stage, I think you already get the game. So it's fine. Now that we are here, we just need to write the final solution. The final solution is going to be what? The positive regions is just x is less than 0, as well as x being greater than 3. That is the first way, the simplest way you can write it. Or accommodating those who just like complicated life. It's going to be x is an element of negative infinity all the way to 0. We exclude that. Union, that is, and not it's or in the language of probability. Yeah, 3 all the way to positive infinity. Okay, it's this side or that side. So usually I think it's better to just stick to this or so that it corresponds with that. You see, because they mean the same thing. If I use and I use this sign, you might think and that sign they go together. Can't, that's not the case. Okay, let's do the last one and avoid the preaching. X plus 2. Okay, nah, that's not the question. Let me write the question. The question is solve for x in this inequality. X plus 2 like that. Okay, again, you can see we have a fraction. So the idea is to eliminate the fraction. We're just going to multiply by the square of the lowest common denominator. So we're just going to do this. This is the LCD that we have. We square it and multiply the left hand side by it. Okay, you don't do that. This is what is happening on the right hand side. Then we multiply by the square of that denominator again. You see? So from there, you know that this one of the 2 is cancelling with that. And then on the left hand side, we are left with x plus 2 times x plus 2 being greater or equals to 4 times x plus 2. Okay, 4 times x plus 2, 4x plus 8. This is x squared plus 2x plus 2x. This is 4x plus 4. Okay, now we just need to move certain things around. So what do? We shift this 4x and 4x will cancel each other. We're going to have x squared minus 4 greater or equals to 0. And then we can have x plus 2 as well as x minus 2 being greater or equals to 0. I hope simplifying is not complicated for you. If it is, you talk and then we simplify it. Critical points. Now we have x equals to negative 2 and x equals to 2. Okay, now we draw a number line as usual. I know some they draw a parabola at this stage. If you feel like that makes sense or it's easier for you, you take that and keep it moving, as long as we arrive at the same solutions without you violating any of the rules, of course. Okay, negative 2 and 2 we shade because there's greater or equals to, that's why we shade. And now we're just gonna look for the signs. So we use that product. This is the product that we're going to use, and we substitute any value of x which is less than negative 2 that side first, and then the answer that we get on that, we substitute for x, if I can just say it like that. The answer we get is positive, and then we substitute for x any value between the two values or the critical points, such as negative 1, we get a negative, and then we substitute a value greater than 2 like 4, we get positive. So now to write our final answer is basically going to be x is actually less than or equals to negative 2, or x is greater or equals to 2. Just like that, you are done. Alternatively, you can write the final answer as x is an element of negative infinity all the way to negative 2, and use the square brackets to include this negative 2, or as a union, you'll start with including this positive 2 all the way to infinity, positive infinity to say, then you will be done. Just two ways of writing the same thing. You don't need to write this and that. Pick one and then you are fine. However, don't try to get away with understanding none of them. You can't get away with that one unless if the definition of getting away for you is with failing. Okay, here is the situation with these questions in particular. Okay, now that you have identified what is happening with this fraction, you know the final solution. Here is the thing about it. You can look at, we said x is greater or equals to 2, or x is less or equals to 2, but think of the inequality that you were given initially. If x is negative 2 there, that means the right hand side is actually divided by 0, which means it is actually undefined. So x cannot be negative 2. I hope you get that, because it will make the inequality undefined, you see. So you need to now come back to your solution and then exclude this negative 2, just like that. That will give you the final solution. So we're going to now do this. Use this circular bracket in your final answer. You see that? That's basically how this solution is supposed to be. And in the previous one, I think all the solutions were valid. From greater than 3, less than 0, we're not saying less or equals to, you see. So we don't need to exclude anything. So we are safe in those instances. So with the fractions, that's one thing you need to look out for. That is it with part 2 of the inequalities. I think I've covered all the types of inequalities that you might need to know about or encounter in an exam situations. We are done. See you in the next video. We're going to look at sets. Subscribe.